Good day, learners. Welcome to another lesson in general mathematics. Today, we will study arithmetic and geometric sequences. In our previous lesson, we learned that patterns help us identify relationships and determine what may come next. Today, we will take this idea further by studying two important types of sequences. We will learn how these sequences behave, identify their important attributes, and use formulas to solve problems. Let us begin. Let me begin with a simple question. How do we make predictions? For example, how do we predict tomorrow's weather? How does a business predict future sales? How do we estimate how much money we may save after several months? Many predictions are made by observing patterns and using past information. If we notice that something changes in a regular way, we may use that pattern to estimate what will happen next. In mathematics, sequences can help us recognize patterns and make predictions. Today, we will study two types of sequences that can be used to describe different patterns of change. At the end of this lesson, you should be able to illustrate the attributes of arithmetic sequences. You should also be able to illustrate the attributes of geometric sequences. Finally, you should be able to solve problems involving arithmetic and geometric sequences. These objectives will guide us throughout our lesson. Let us begin with an arithmetic sequence. An arithmetic sequence is a sequence in which consecutive terms differ by a constant amount. This constant amount is called the common difference, represented by the letter D. Consider the sequence 3, 7, 11, 15, and so on. Let us examine the difference between consecutive terms. 7 minus 3 is 4. 11 minus 7 is also 4. 15 minus 11 is again 4. Therefore, the common difference is positive 4. Because the difference between consecutive terms is constant, this is an arithmetic sequence. An arithmetic sequence has several important attributes. First, it has a constant common difference. Second, the terms increase or decrease by the same amount. For example, if the common difference is positive 5, we add 5 to each term to obtain the next term. If the common difference is negative 5, we subtract 5 from each term. We can also determine any term of an arithmetic sequence using a formula. The formula is a sub n equals a sub 1 plus the quantity n minus 1 times d. In this formula, a sub n represents the term we are looking for. A sub 1 is the first term. N is the position of the term. And d is the common difference. This formula is particularly useful when we need to find a term that is far from the beginning of the sequence. Let us apply the formula. Find the 25th term of the sequence. 8, 13, 18, 23, and so on. First, identify the given values. The first term is 8. The common difference is 5 because 13 minus 8 equals 5. We are looking for the 25th term, so n is 25. Now, substitute these values into the arithmetic sequence formula. A sub 25 equals 8 plus the quantity 25 minus 1 times 5. 25 minus 1 is 24. 24 times 5 is 120. Then, add 8. The answer is 128. Therefore, the 25th term of the sequence is 128. Notice that we did not need to list all 25 terms. The formula allowed us to determine the answer directly. Now let us discuss a geometric sequence. A geometric sequence is a sequence in which consecutive terms are multiplied or divided by a constant ratio. This constant value is called the common ratio, represented by the letter R. Consider the sequence 2, 6, 18, 54, and so on. Let us examine the relationship between consecutive terms. 2 multiplied by 3 is 6. 6 multiplied by 3 is 18. 18 multiplied by 3 is 54. Therefore, the common ratio is 3. Because each term is multiplied by the same number, this is a geometric sequence. A geometric sequence also has important attributes. First, it has a constant common ratio. Second, the terms are multiplied or divided by the same number. To determine the common ratio, we may divide a term by the preceding term. For example, 6 divided by 2 equals 3. 18 divided by 6 also equals 3. We can determine any term of a geometric sequence using a formula. The formula is, a sub n equals a sub 1 times a raised to the quantity n minus 1. Here, a sub n represents the term we are looking for. A sub 1 is the first term. R is the common ratio. And n represents the position of the term. Just like the arithmetic sequence formula, this formula allows us to determine a particular term without listing every term before it. Let us apply the geometric sequence formula. Find the 10th term of the sequence. 3, 6, 12, 24, and so on. First, identify the given values. The first term is 3. The common ratio is 2 because 6 divided by 3 equals 2. We are looking for the 10th term, so n is 10. Now, substitute these values into the formula. A sub 10 equals 3 times 2 raised to the quantity 10 minus 1. 10 minus 1 is 9. Therefore, we have 3 times 2 raised to the 9th power. 2 raised to the 9th power is 512. 3 times 512 is 1536. Therefore, the 10th term is 1536. Arithmetic and geometric sequences are useful in solving real-life problems. The important question is, how do we know which sequence to use? Arithmetic sequences model constant increases or decreases. If a quantity increases by 20 pesos every week, that is a constant increase. If the value decreases by 5 units every month, that is a constant decrease. These situations may be modeled using an arithmetic sequence. Geometric sequences, on the other hand, model repeated multiplication, growth, or decay. For example, if an investment increases by 25% every year, each new amount is based on the previous amount. If a machine loses 10% of its value each year, the new value is also based on the previous value. These situations may be modeled using geometric sequences. Remember, a constant amount of change suggests an arithmetic sequence, while a constant ratio or rate of growth or decay suggests a geometric sequence. Let us solve a word problem. A student's allowance increases by 20 pesos weekly, starting at 100 pesos. Find the allowance on the 8th week. Before using a formula, let us analyze the problem. The allowance increases by 20 pesos every week. The increase is a constant amount. Therefore, this situation represents an arithmetic sequence. The first term is 100 pesos. The common difference is 20 pesos. And we are looking for the 8th term. Let us now solve the problem. We will use the formula for the nth term of an arithmetic sequence. The first term is 100. The common difference is 20. And n is 8. Substitute the given values into the formula. A sub 8 equals 100 plus the quantity 8 minus 1 times 20. 8 minus 1 is 7. 7 times 20 is 140. Then, add 100. The answer is 240. Therefore, the student's allowance on the 8th week is 240 pesos. The formula allowed us to predict the allowance on a particular week based on the pattern of increase. Let us summarize the important concepts we learned today. An arithmetic sequence has a common difference. Its terms increase or decrease by a constant amount. A geometric sequence has a common ratio. Its terms are multiplied or divided by the same number. We also learned that formulas help us determine any term of a sequence without listing all the preceding terms. Arithmetic sequences may be used to model constant increases or decreases. Geometric sequences may be used to model repeated growth or decay. Most importantly, sequences help us identify patterns and make predictions. Let us reflect on our lesson. Why do we need to make predictions? Think about your daily life. We make predictions when we estimate our future expenses. Businesses predict future sales. Farmers may consider weather patterns when planning their activities. Families may estimate how much they can save after several months. Predictions help us prepare, plan, and make better decisions. Now, think of other situations in daily life where predictions are important. How can recognizing patterns help us make better predictions? Today, we learned how arithmetic and geometric sequences describe different patterns of change. We learned that arithmetic sequences involve a constant difference, while geometric sequences involve a constant ratio. We also used formulas to determine particular terms and solve a real-life problem. Remember that recognizing patterns is not only a mathematical skill. Patterns help us understand changes, make predictions, and prepare for possible future situations. Continue practicing how to identify arithmetic and geometric sequences and how to apply their formulas. Thank you for your active participation. See you in our next lesson.